So over the past couple of days, you've looked at graphs of polar functions. So today we're going to kind of summarize all of that. So again, for polar functions, just as a reminder, the inputs are our angle and the outputs is our radius. So here's some phrasing that you might see. The graph of a polar function r equals f of theta, where f of theta equals this, is shown in the polar coordinate system. So that's referring to like that polar graph, and we'll say that polar coordinate system. So again, you might not remember all of the graphs we did. You're like, what makes a circle? What makes a rose? What makes a limacon? Does it have a dent? All that kind of stuff. But one way to do that is by graphing with a table. So what I want you to do is make sure your calculator is in radians, and I want you to, well, actually we could do this without, because we're graphing with the sine of theta. So we're going to plug in these values. So 3 minus 3, the sine of 0. Well, the sine of 0 is 0. So 3 minus 3 times 0 is 3. Well, pi over 6. So if I was to go and replace this with pi over 6, the sine of pi over 6 is half. So 3 minus half is 1.5. Pi over 4, well, that'd be root 2 over 2. And again, you might need a calculator to run through some of these. And you could keep going. And you could make this table. And again, you'll probably see, oops, I got off here a little bit. This one's 0.4019, 0.8787. And then you could graph this. So again, our angle and our radius. So 0 and 3. All right, pi over 6 and 1.5. So is this one pi over 6? Pi over 2 and 0. I'm going to graph the ones that are easiest. Pi and 3. So 2. So 3 has to be right about there. Is there another 3 pi over 2 and 6? All right, and if we kept graphing this, we would see that this is, oops, one of these with the dent, right? Because those absolute values are the same. So, and we talked about yesterday how they often have symmetry. Now, these will only appear on the AP to examine multiple choice. You won't be asked to sketch it, right? And if you can, again, remember all that stuff, it's pretty easy. But we want to talk a little bit about how doing these multiple choice ones, if you can just find a value, you can answer some of these. So, for example, in this figure here, which of the followings could be an expression? So you might remember that this is a rose, but if you don't, let's start with an easy coordinate. What would, let's see, f of 0. So we know from our graph, f of 0 has to equal 0, okay? So let's plug in 0 for our thetas. So 3, the cosine of 3 times 0. So that's 3, the cosine of 0. And what is our cosine at 0 is 1. So 3 times 1. So it's not that one. So this would be 3 times not that one. So we can eliminate those two. Okay, well, let's try another one. Let's try, so we have sine, okay? So I'm going to try, what if I did pi over 6? So this would be negative, if I looked at b, negative 3, the sine of 3 times pi over 6. Well, negative 3 times, let's see, the sine of, that would be pi over 2, right? And the sine of pi over 2 is 1, so that would be negative 3. Well, looking at pi over 3, it doesn't go in a negative 3 direction, so it's got to be this, because this would be 3, the sine of 3 times pi over 6. So 3 times the sine of pi over 2. So 3 times 1, which is 3. And pi over 6, it looks like that is probably more at the 3. All right, so this next one here, example 2. The figure shows the graph of the polar function. Which of the following could be an expression for it? And again, so if you memorize all those, it gets a lot easier, right? If you can memorize them. But again, I'm not expecting you to memorize, but this is where we use multiple choice. So let's try 0 again. So f of 0 is 2. Okay? So when our angle is 0, so what is the sine of 0? So this one, 2 plus 4 times the sine at 0. Well, our sine at 0 is 0. So this would be 2 plus 4 times 0, which is 2. So it could be that one. Well, what's the cosine at 0 is 1. So it can't be that one. So it can't be our other cosine. So possibly this one, right? Those two. So let's pick another angle. I'm going to look at, if I look at pi over 2, so if I face that, the sine of pi over 2 is negative 2. Okay, so if I did the sine of pi over 2, 2 plus 4 times the sine of pi over 2, 2 plus 4 times 1, that gives us 6. Whereas this one, 2 minus 4 times the sine of pi over 2, 2 minus 4 times 1 is negative 2. So it has to be letter B. All right, example 4. A portion of the graph of the polar function f of theta, where here's our polar graph, is shown in the system. Which of the following, if A is less than theta is less than B, if 0 is less than A is less than B is less than 2 pi, which of the following could be true? All right, so we got to figure out even what this one is saying here, all right? So we have our graph right here. And it looks like this is just a circle, right? This is the one I remember, so it has between 0 and negative 3. So we have to figure out between what values gives us this graph, okay? So again, we have to kind of think of that walking forward and backwards bit. If our angle is positive, right? Because our angles are between A and B. Theta is between A and B is between 0 and 2 pi. So it's saying if our angle, it's a positive angle. Okay, so let's think about how we get some of these. So if I'm turning, right, thinking about you got to think if we're standing right here in the middle, I'm facing, there's no graph, no graph, no graph. But if I face this way and I walk backwards, I would end up with a point here. If I face this way, walk backwards. So all these places I could walk backwards until pi, and I'd get that. As soon as I turn past pi, there's no graph. So it would be letter B, between pi over 2 and pi. All right, the next one. So similar. Here's another portion of the graph is shown. A and B are positive angles, again, because theta is between A and B are between 0 and 2 pi. Which of the following could be angles? So again, think if you're standing at that door origin, if I face a 0, there's a graph. So until what angle is there no graph? Well, it stops right about here. So I'm going to eliminate this one. I'm going to eliminate this one. So it's between 0 and something. Is that probably pi over 3 or pi over 6? I would say letter D. Okay. And this next one here. Here's another graph. Okay. So, and again, I kind of skim these and try and see what I think is important. The figure shows the graph of the polar function. So here's our polar function. There are 4 points labeled A, B, C, and D between 0 and 2 pi, so positive angles again. The domain is restricted to pi over 3 and 2 pi over 3. So if I restrict it to pi over 3 and 2 pi over 3, okay, so thinking pi over 3 and 2 pi over 3, the portion of the graph that remains is consistent of 2 pieces. One of those pieces is the portion that is in quadrant 3 from C to D. Which of the other describes that? All right. So pi over 3. Well, first of all, I know that this is pi over 4. So let's see if we can figure out exactly where pi over 2 is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is pi over 12, 2 pi over 12. So that's pi over 6, 3 pi over 12, 4 pi over 12. So this is pi over 3. So I'm going to darken in, I'm going to highlight that. So 5 pi, 6 pi, 7 pi, 8 pi over 12. Which is 2 pi over 3. So it's in between these, right? So I'm thinking if I go forwards and backwards, so in between pi over 3 and 2 pi over 3. So if I face those, if I face pi over 3 and walk backwards, and if I face pi over 2 pi over 3 and walk backwards. So it's this part right here, right? Because if I was to walk here, I need to re-highlight it. So it's talking about this angle right here. Because if I was to face pi over 3 and walk backwards, I'd get this. And as I turn, I'd end up here. So let's see, what's the other chunk? Well, I could get this chunk by just walking forwards. So is A to D 1? Yep, from D to A, right here.